So let's take a look at this quadratic function. So it's a quadratic because we have a polynomial of degree 2 and it's a function. So remember, a solution here is going to be an x and a y. An x goes in, the answer is a y. So they ask us to find the vertex, and there are two ways to find the vertex for a quadratic function. One way is to read the transformations, the horizontal and vertical shifts, but when it's in this form, which often refer to this as standard form because it's an ax squared plus bx plus c, then we can't just look at it and read off how far left, right, up, and down the graph has been shifted. So there's a formula we can use, negative b over 2a, and that'll help us find the vertex. So b and a are the same values as in the quadratic formula. So negative b is 14, a is 2. If we reduce this, we get negative 14 on top, 4 on bottom, which reduces to 7 over 2. As a decimal, normally we leave it as a fraction, but let's just call this negative 3.5. So we can take that value and substitute into our function and get the corresponding y. Anytime you know an x, plug it into your formula and it'll tell you y. So the function is 2 times our x, where x is negative 3.5 squared. And then we're going to add the result of 14 times x. So parenthesis 14 times negative 3.5 plus 20. So we get negative 4.5. So that's our vertex. So let's plot that. Let's pull up a graph. So if we take a look at our graph, our x is negative 3.5, our y is negative 4.5, so we would be about here. So these have what are known as axes of symmetry. Parabolas are symmetric, and the axis of symmetry goes right through the middle of the graph. So remember, a parabola looks like this. The vertex is here. One side is a reflection or a mirror image of the other. And that's going to help us when it comes to plotting this. So let's make a table. We know that when x is negative 3.5, y is negative 4.5. So let's pick two x's to the right of that. Let's use negative 3 and negative 2. And let's plug those into our function and find out what y goes with them. So I'm just going to pull up my calculator and I'm going to put in a negative 3. So we have 2 times negative 3 squared, which is 18, plus 14 times negative 3, plus 20, so that's negative 4. Then if we put a negative 2 in, we have 2 times negative 2 squared, plus 14 times negative 2 plus 20, and we get 0. So negative 3, negative 4, and negative 2, 0. So we can plot those points, negative 3, negative 4, and negative 2, 0. So on the right side, our parabola looks like this. We can reflect each of those points across the axis of symmetry to get the other side. So this point is a half unit to the right of the axis of symmetry. This one is a half unit to the left. This point is 1.5 to the right. That one's 1.5 to the left. So we're able to reflect it across that axis, and we can get our graph. So we've got our vertex. The axis of symmetry is an equation, and a vertical line is always x equals something. At that axis of symmetry, the x is negative 3.5. Notice for our vertex, the x is negative 3.5. Then it asks us whether we have a maximum or a minimum. This graph has a lowest point. So we have a minimum of negative 4.5 because that's how low our parabola goes. That's the vertex. And then we graphed it. All right, this one they want us to find the correct graph, but we will graph it by hand, and then you could match it. Let's see. Oops. Where did we go? Okay. So when we're in this format, let's think about that. Our basic parabola, y equals x squared. If we were to make a table, would look like this. If we put a 0, a 1, and a 2 in, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Negative 1 squared is 1, negative 2 squared is 4, negative 3 squared is 9. So that's what a standard parabola looks like. If we add or subtract a number from the whole function, that makes our graph go up or down. If we're adding, it moves it up 3 units. So if we were to have x squared plus 3, then our new vertex, instead of being at the origin, would be here at 3. If we had minus 5, then our parabola would be the same shape, except it would go down 5 units. So whatever that number is that's added or subtracted to the function, that determines how much we go up or down. Notice we also have a number added or subtracted directly to the x. That determines how much right or left we go. But this is a little trickier. For the vertical shift, we go the same direction as the sign, meaning that up is positive, down is negative. For a horizontal shift, we go the opposite. So here we have a positive, we actually shift it to the left. If we had a negative, we would go to the right. So if it's x plus 3 squared, we go opposite of positive, so we go to the left 3. If it's x minus 3 squared, opposite of a negative would be to the right, so we go right 3. So those are our shifts. So if we look at this example, get my pen back. So this part, since it's attached to the x, it moves it in the x direction, opposite of the sign, so it moves it to the left 3. This part, that's not attached to the x, so that affects the y direction and it goes the same as the sign, so it goes up 3. So imagine we take our vertex and move it to the left 3, up 3, then our new vertex would be minus 3 plus 3. To the left 3, up 3. So that's where our vertex is going to be located. So let's plot that, negative 3 plus 3. Make a little table on the side. So let's pick 2 points to the right, so -2 and -1. If we were to plug a -2 into our function, we would have -2 plus 3 on the inside. That would get squared. Then we would, I hit the wrong button. So if we plug a -2 in, we would add 3 to it. That would get squared. And then we'd multiply that times 1/2. And then we would add 3. So we would get 3.5. If we substitute in a -1, we would have -1 plus 3. That gets squared times 1/2. And then we would add 3 to that. So that would give us 5. Remember, the axis of symmetry goes through the vertex, and the equation is going to be x equals -3 because the vertex is at -3. And then if we plot these points, we have -2, 3.5, -1, 1, 5. So we're doing this. And then we can reflect those across the axis of symmetry. So this point is to the right one, so we're going to go to the left one. This point's to the right 2, so we're going to go to the left 2, same y value, just to the left. And there's our parabola. It has a minimum of 3. 3 is the lowest y value on the graph. All right, so they give us a graph and they ask us several questions. So first of all, they say find the vertex. So this is not in the format that we can read the vertical shifts and the horizontal shifts. So we need to use the formula. So negative, and b is also negative, over 2 times a. A is 1. So we get 8 over 2, which is 4. So that's the x-coordinate of the vertex. If we substitute that in, we have 4 squared minus 8 times 4 plus 15, which is -1. Now, one thing I did not mention on the other ones, but that the coefficient of x squared was positive on all of the other parabolas, and our parabolas went this way. If the coefficient of x squared is ever negative, then our parabola will be flipped upside down and go the other way. We're not going to memorize how wide the parabola is or how narrow it is based on the coefficient of x squared. Once we get the vertex, we're just going to use some additional data points to plot it, and that's going to let us know how wide it is. This one doesn't actually ask us to graph it, so I'm just going to make a sketch for reference. So 4, -1 is the vertex, and since our coefficient is positive, our parabola goes this way. Now, if I ask you to graph it on the test, I need some more points so we can be more detailed. But if we're just asked the questions here and not really specifically told to graph it, then this is accurate enough. So it says determine if we have a max or a min. So this one has a min, and that minimum value is -1 because that's the y value at the vertex. It asks us for the range. Remember, the range is the y values, so the lowest y value is -1, and it goes up and up and up and never stops going. So at -1, we put a bracket because we do have a point at -1. Then the last part asks us, where are we increasing or decreasing? So the first section of the graph is going down, so it's decreasing. remember, when we're reading increasing or decreasing, we're reading left to right. So how far to the left does it go? It goes to negative infinity, and it stops going down when we get to this x value. The x value there at the vertex is 4. And then we start decreasing. I'm sorry, that I said that. I think I said it correctly. I wrote it wrong. We're decreasing from negative infinity to 4. The next section of the graph is going up, so the next section is increasing. So we're increasing, increasing, increasing. So starting at an x value of 4, we're going up, and no matter how far to the right we go, our graph is still going to be going up. So we're increasing from 4 to infinity. So decreasing to begin with, and then increasing after that. Now the last question is an application where we're trying to maximize or minimize something. So we're given that we have a piece of plastic that's a rectangle. And we're going to fold this piece of rectangle, this piece of plastic. Can't talk today. Let me do this. So we're going to fold it here, and we're going to fold it here. And imagine that if we were to fold the ends up, fold this part towards the middle and fold this towards the middle, of course, it'd be doing the same thing on the other end, then we would get something that looked like that. And when we do that, it's going to be three-dimensional. It's no longer going to be flat. So they're using x to represent the height. That. So the height is going to be determined by where we put that crease, where we put the bend. So that's x. And down here, that would also be x, because we want both sides to be the same height. Now we're told that this is 8, and this total distance is 12. So we need to come up with an expression for this part, because that part is going to be how thick the file compartment is. 8 is the width of the file compartment. X represents the height of it, but this part here in the middle, that's going to represent the thickness of it. So if the whole length is 12, and we don't use that, so we're taking away an x and another x. So we're taking away 2 x's. So this distance and that distance combined makes 2 x's. We're taking that away from the whole distance, and that gives us what's left over. The whole minus what we're not counting, and that tells us that part. So that distance we would describe as 12 minus 2x. So depending on where we put that fold, we would have, if we put that fold really close to the end, if we put it, let's say, right here and right here, then it would not be very tall, but it would be very thick. On the other hand, fix that. If we put it almost in the middle, we put the folds there, then it would be tall, but it would have almost no thickness. So the first way, we could make it thick but not very tall, or we could make it tall and not very thick. We're wanting to find out, how can we make it have the most volume possible? So where does this line need to be so that when we fold it, it's as large as possible? So if we think about this This is basically a cube. If we imagine lines going across there, that's a box, that's a prism. So we have a volume that's length times width times height. So one of those directions is 8. If we call the length 8, we call that 8, then the width would be 12 minus 2x. Let's see, there we go. And the height would be x. So depending on what that distance to the fold is, that's going to affect what our volume is. Now we could just pick a distance, plug it in and find a volume, pick a distance, plug it in and find the volume, but we might not be guaranteed to find the largest volume doing it that way. What do I mean? We talked about this illustration up here about picking different distances from the edge to make our fold. We could say, well, if our distance from the edge is 1 unit, what would that volume be? If our fold is, let's say, 3 units from the edge, what would that volume be? But there'd be lots and lots of combinations to try, and we still might not find the one that gives us the largest volume. So what we're going to do is, here is a function that x tells us the thickness or the width, and that corresponds to v, which is the volume that we've created. So if we were to graph it, in the x direction we would have the thickness, and the y direction we would have the volume. So let's see what this is going to look like. Let's get rid of the parentheses. So I'm going to rearrange this and call this 8 times x, and then times the parentheses. And if we distribute this, 8x times 12 is 96x. 8x times minus 2x is minus 16x squared. So this is a quadratic function. It's a quadratic function that has a negative leading coefficient. So it's a parabola that's going to look like this. So we're going to have a maximum. If we were to put 0 into our function, notice v of 0 would be 0. 0 squared times 16, 96 times 0, and then add those together, we would get 0. Meaning that if we didn't put a crease in the end, or put a crease in it, we would have no volume. We would just have a flat surface. But then as we work our way to larger and larger x values, then our volume is getting bigger and bigger and bigger. But there's going to reach a point where if we let our x value get larger, our volume starts coming back down. And in fact, if we were to put our crease right in the middle, imagine folding a piece of paper in half, then we would not have any volume. We would have a width and a height, but we would have no thickness. We would have a thickness of 0. So if we had a thickness of 0, no volume. So that's what that point represents. So our maximum is going to be somewhere in the middle. So we just need to find out where the vertex of our parabola is. So x is negative b over 2a. So negative 96 over twice negative 16. So negative 96 over negative 32. So x is positive 3. So that's how far from the end our fold needs to be. The units on these are inches. So how tall should it be to get the largest volume? X stands for the height, so it should be 3 inches tall. If we wanted to know what the actual maximum volume is, 3 is just the height of the file, the X value. We could plug that 3 into our function, and that would tell us what the actual volume is. That is the maximum volume.